Hi everyone, in this video we're going to go through IXL assignment VLM, Identify Equivalent Expressions Involving Exponents, Part 1. Before we switch over to IXL, this graphic right here is a very handy tool as you're working on learning the properties of exponents, which is something that you need to use in the IXL assignment. If you don't already have a copy of this from either class or from our class notes section OMHS, I would pause the video, take a screenshot real quick so you can have this handy when you're working on the IXL assignment. All right, let's get started on IXL. All right, so let's take a look at our screen right here. As you can see on the left, we have our little anchor chart that we'll be using. And then on the right, we have our IXL assignment. So VLM, Identify Equivalent Expressions Involving Exponents, Part 1. First question, we want to know which expression is equivalent to 3 to the 7th times 3 to the 6th. The first thing I look for is what is the operation? So remember, operation means addition, subtraction, multiplication, division, that is occurring between our two powers. So our first power is 3 to the 7th, and then our second power is 3 to the 6th. Well, I can see that dot right there, meaning they're being multiplied. So now that I know these two powers are being multiplied, let's look at our chart and see which rule matches that. That would be this one right here in green, the product of powers. Because remember, product is the word for answer to a multiplication problem. And this rule tells us that if you're multiplying two powers with the same base, which I do have, they both have a base of 3, I can simplify that by adding the exponents. So we're going to add our exponents. Let's go ahead and write this one out here so we can see it. Since we have 3 to the 7th times 3 to the 6th, they're being multiplied, same base. I can simplify that by adding my exponents. 7 plus 6 is 13, which means 3 to the 13th is our simplified answer, and that is equivalent. That is equal to this original expression. Just one is simplified, one is not, but they're still equal. You do always want to check and see if there's multiple answers, but in this case, it's not a multi-select. You don't have those little check marks. So we don't need to select more than one answer. There is just one that is true. All right, let's check this one out. Which expression is equivalent to 10 to the 10th? And then that fraction bar, which in this case is being used as division, 10 to the 5th. So we have 10 to the 10th divided by 10 to the 5th. Fractions are a lot of times used to represent division because fractions are a division problem. Just sometimes they're simplified because you don't have enough. Other times we need to simplify them. Our numerator is way bigger. We got way more up there, 10 to the 10th. So we want to simplify this fraction. We want to do that division. Let's look at our little chart over here to the left. Which property does that match? That would be this one down here in dark green, quotient of powers. So remember, quotient is the word for answer to a division problem. And it tells us that if we have two powers with the same base, A and A, and on our example here, 10 and 10, same base, so we're good to go. When they're being divided, we can simplify that by subtracting our exponents. So we have 10 to the 10th divided by 10 to the 5th. They have the same base, and our property of exponent tells us that when this happens, we can simplify by subtracting our exponents. 10 minus 5 is 5, meaning 10 to the 5th is our simplified answer, and it is our equivalent, our equal expression. Oops, I guess I forgot to click it, but that's the nice thing is I'm going to hit that again so you guys can see it. That if you ever accidentally click submit but didn't really hit the answer, it gives you a nice reminder so you don't miss it and lose any points. All right, let's check out this property here. Which expression is equivalent to 3 to the 9th raised to the power of 4? Notice how this one looks different from our first problem because I don't have two different powers being multiplied. It doesn't say 3 to the 9th times 3 to the 4th. It says 3 to the 9th, that whole thing in parentheses there is being raised to another exponent. So we have an exponent being raised to another exponent. Another way of saying that is right here in blue. We have a power, 3 to the 9th, being raised to another power, the 4th. To simplify that, we can multiply our exponents. Get back to our drawing tool here. So we can multiply our exponents. So we need to take 9 times 4. And 9 times 4 is 3 to the 36th power. And once again, they don't have those little check marks, so there isn't more than one answer. So I am good to go. Ooh, this is a fun one. What do we do when the bases aren't the same? Oh, maybe I jumped the gun. I probably should have read the problem first out loud. Which expression is equivalent to 12 to the 5th divided by 6 to the 5th? In order for this quotient of powers property to work, our bases have to be the same. And are they the same? No, 12 and 6 are not the same number. When this occurs, we just got to go old school. We don't have a property. We don't have a little shortcut that makes our work faster. We'll just need to figure out what 12 to the 5th is and divide it by 6 to the 5th. This is a case where you do have permission to use a calculator because our numbers are going to get very large. That happens with exponents. All right, let's pull out our calculator here and see what 12 to the 5th is. Actually, let me show you a great little calculator tool that you can use if you don't already have one that you like. All right, this is a free online calculator. It's called Desmos Scientific Calculator, and it allows us to put exponents in really quickly. So we have 12 to the 5th. We can go 12, and then this little button right here that says AB, that allows us to go into exponent mode and make the exponent whatever we want. Yikes, that's a large number. So I'm going to hit enter so it saves it up here. And then it's divided by 6 to the 5th. So 6th, press this little button to the 5th. All right, that's a really big number. So let's divide them out. So we have 248,832 divided by 7,776, and that gives us the answer of 32. All right, I'm going to write this here so I don't forget it. So we know that one equivalent expression is 32. But do any of our answer choices say 32? No, because our answer choices left us an exponential form. So let's look through these and see which one of these would also be equivalent, would also be equal to 32. My eye immediately goes to this first one right here. That's just a 2. That only has an exponent of 1. It's not going to change any. So that's not it. Then the next thing my eye goes to is this last one, 2 to the 0. What is anything to the 0 power? 1. So that's equivalent to 1, which is definitely not 32. That means we only have two to look at. One's a fraction and one's not. Pretty good idea what the answer is going to be, but let's use our calculator to make sure and see what 2 to the 5th is. So 2 to the 5th power is also 32. That right there is our equivalent expression. All right, let's jump up a level here. This is a good one. This is a good one. All right. We want to know which expression is equivalent to 12 to the 36th divided by 12 to the 6th. Let's go ahead and simplify that. I can see divisions going on. The bases are the same. They're both a 12, which means I can use my quotient of powers and subtract my exponents. Well, 36 minus 6 is 30. So we have 12 to the 30th. Do any of these say 12 to the 30th? No. So even though I could use one of my rules, this one reminds me of our last question, where now we have to go through those answer choices and find one of those that is equivalent, that is also equal to 12 to the 30th. So if we look at the first one here, that is a fraction, and there's no negatives involved, so I don't need to simplify or change anything. So that's not it. All right, this one is our product property. I have 12 to the 3rd times 12 squared. If we add our exponents, 3 plus 2 is 5. Nope, that's not it. Our next one, we have a power to a power property. Remember, with power to a power, you multiply those exponents. So 4 times 2 is 8. Nope, that's not it. Let's hope this last one works. Power to a power property again, 12 to the 5th. Being raised to the 6th. That's this property. 12, and then 5 times 6 is 30. Whew, look at that. These two end up both getting the same answer. Therefore, they're equivalent. Therefore, they're equal because you receive the same answer. All right, let's see if we can find one with negatives, and then that will be our final question for this video. Perfect, here is one with negative numbers. All right, even though, hopefully you recall that we have a property, let's circle it right down here, that tells us we can have negative bases, we can have negative numbers, just when we're simplifying something, our exponent should not be negative. If it is, then there's more work to be done. It's not simplified completely. I don't ever really worry about the negatives until I'm all done with everything else, because sometimes they end up going away and I don't have to worry about them. Other times I do, but I find it easier just to do that at the very end. So yes, there's a negative involved, but we're going to go forward as normal and see if it remains when we are finished with applying our other properties. So we have 8 to the negative 7th times 8 to the 5th. Well, I can see that these two powers are being multiplied, meaning I will use this rule, and I need to add my exponents together. So 8 to the negative 7 plus 5. Negative 7 plus 5, remember negative 7 is all the way to the left on the number line. If we add 5, that moves us to the right, and we would land at negative 2. Well, that right there, I have a negative in my answer, meaning I want to simplify it completely and see what it would be as a positive. We look down at the negative rule that I circled initially. Whenever we have a negative exponent, if we move it to the other side of the fraction, just that power that's negative, if we move that portion to the other side of the fraction, it becomes positive. You might be thinking, well, Mrs. Elstock, that's not a fraction. No, but we can rewrite it as one. How can you rewrite any number as a fraction? Put it over 1. Now that it's a fraction, if we move our power that has a negative exponent to the other side, so in this case, the denominator, that makes it positive. All right, do any of our answer choices say that? Oh, bummer, they don't. Well, if we look here, we are in the challenge zone, so we are going to have to do a little bit more work to see which of these is equivalent. Before I do that, let's always use that process of elimination, see if there's some answer choices that are very clearly wrong. My brain first goes to the last one here, a to the negative 35th. Even if I made that a positive exponent, which would be 1 over a to the 35th, does that match? Nope. All right, how about this second one here, 1 over a to the negative 2? Well, it needs to be a positive 2 in the denominator, and if I were to take that negative exponent and make it positive, which would be a squared, that still doesn't match, because that would be like saying 4 and 1/4 are the same. No, they're not. So that doesn't work. All right, let's look at this middle one here. I see a 0 exponent because that's always my favorite. All right, we have power to a power here, and that power to a power tells us that we can simplify by multiplying. So 0 times negative 2 is 0, which means we have 8 to the 0 power, which is 1. So does that one work? No, it doesn't. So we are left with only one option. So sometimes, even though you have to do a little bit more work if you get up into that challenge zone, use that process of elimination. It can help make it go through pretty quickly. All right. As always, if you have any questions and this video wasn't quite enough for you, remember that IXL has its own little tutorial. So when you're on the assignment, right here's a tutorial button, and they have a nice little video you can watch, because sometimes just seeing it from a different point of view will make things click. And then, of course, you can always come to help sessions or send me an email. So good luck, guys. You got this.